Hello and welcome. Our topic for the day is writing the first n terms of a geometric sequence. Let's understand what a geometric sequence is and the nth term, and then we'll do some questions. So we start reading. If a sequence of values follows a pattern of multiplying a fixed amount, not zero, times each term to arrive at the following term, it is called a geometric sequence. The number multiplied each time is a constant, that it is always the same. The fixed amount multiplied is called the common ratio and is denoted by the letter R, referring to the fact that the ratio of the second term to the first term yields the common multiple. When we divide the second term by the first term, we'll get this common multiple, and this would be the common ratio R. So to find the common ratio, we divide the second term by the first term. When we divide the second term by the first term, we'll get the common ratio R. To find any term of a geometric sequence, we use the formula an equals a1 times r to the power of n minus 1, where a1 is the first term of the sequence, r is the common ratio, and n is the number of terms to find. So let's do some questions. Write the first 5 terms of the geometric sequence. Here we given the nth term of the geometric sequence, an equals to negative 2 times negative 6 to the power of n minus 1. It says find the first 5 terms. So we'll start putting the values of n from 1 to 5 to find out the first 5 terms. So we'll plug first n equals to 1. This will give us the first term, a1 equals to negative 2 negative 6 to the power of 1 minus 1. This is equals to negative 2 times negative 6 to the power of 0. This is equals to negative 2 only, because anything to the power of 0 is 1, and 1 multiplied by negative 2 is a negative 2. So this is our first term of the sequence. Now to find out the second term, we'll plug n equals to 2. a2 equals to negative 2 times negative 6 to the power of 2 minus 1. This is equal to negative 2 negative 6 to the power of 1, which is equal to negative 2 times negative 2 is a positive 12. This is our second term of the sequence. Now we plug n equals to 3. a3 equals to negative 2 times negative 6 to the power of 3 minus 1. This is equals to negative 2 negative 6 to the power of 2. Negative 6 to the power of 2 is a positive 36. Positive 36 times negative 2 is a negative 72 is our a3. This is our a3. So let's find a4. We plug n equals to 4. Therefore a4 equals negative 2 times negative 6 to the power of 4 minus 1, because n equals to 4. So from here we get negative 2 times negative 6 to the power of 4 minus 1 is a 3. So when we solve this, we get the value of a positive 432. Similarly, we'll find out n equals to 5, the fifth term. This equals to negative 2 times negative 6 to the power of 5 minus 1 equals to 4. When we solve this with the calculator, we'll get the answer of negative 2592. This is our a5, and this was our a4, 432. So finally our sequence of the first 5 terms we'll write here on the top: negative 2 comma 12 comma negative 72, 432, and negative 2592. This is our first 5 terms of the sequence, which can be seen in option B. Let's try the next one. Write the first 5 terms of the geometric sequence an equals negative 8 to the power of n minus 1. Let's try this question with another method over here. Now this, we know that the nth term or the any term of the sequence is a1 times r to the power of n minus 1. So let's change this nth term to something similar to the formula that we have over here. Let's write this as 1 times negative 8 to the power of n minus 1. If we compare this to the formula over here, we find out that a1 equals 1 and r equals negative 8. So a1 is 1 while r is negative 8. As we learned that each term is obtained by multiplying the previous term with r. So starting, the first term would be 1. 1 when multiplied with negative 8 will give us the next term, that is negative 8. Negative 8 multiplied with negative 8 will give us the next term, that is a positive 64. 64 multiplied with negative 8 will give us negative 512. So we have 1, 2, 3, 4. We'll find out another term. We'll multiply this with negative 8 and we get 4096. So finally our sequence would become 1, negative 8, 64, negative 512 and a positive 4096. So we saw that this was an easier method because it involved lesser of calculations. So chances of going wrong is less. We can use either of the methods. So let's do the next question. Oh, here we have to correct for the right choice, that is option A. Let's look at the next question. Write the first 5 terms of the geometric sequence an equals 3 times negative 4 to the power of n minus 1. So from here we compare it to an equals to a1 times r to the power of n minus 1. From here a1 equals to 3 and r equals negative 4. So we know a1 is 3, so we write the first term. For a2 we'll multiply it with negative 4, the first term. We get negative 12. Negative 12 multiplied with negative 4 will give us 48. 48 multiplied with negative 4 will give us negative 192. Negative 192 multiplied with negative 4 will give us 768. This is 1, 2, 3, 4, 5. So we've got the first 5 terms. We stop over here. So our final answer is 3, negative 12, 48, negative 192 and 768. This is the final answer. Can be seen in option B. Moving on to the next question. Write the first 5 terms of the geometric sequence where an is given by 3 to the power of n minus 1. We'll slightly modify this as an equals to 1 times 3 to the power of n minus 1. Comparing it to the standard formula a1 r over n minus 1, r to the power of n minus 1, sorry. So a1 equals 1 and r equals 3. Now a1 is 1, so we write the first term. The next term is obtained by multiplying with the common ratio. So 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So we've got the 5 terms 1, 3, 9, 27 and 81. This is the final answer that we have, which can be seen in option D. I hope writing the first n terms of a geometric sequence is easy now. Thank you for watching and have a nice day.